Hi there, welcome to your second video on complex numbers. We're going to do a short review here. The first thing on the review is what the heck is an imaginary number? It's a constant that represents the square root of -1. When simplifying negative roots, use that I. So the square root of -64 becomes 8i. The square root of -200, which will break down to 100 square root of 100 times the square root of 2 times the square root of -1. That simplifies to 10i root 2. Square root of -13. 13 does not have a square or a perfect square factor, so it's just I root 13. Okay, now complex numbers is two parts. The first part is A, which is the real part. And then we have BI, which is the imaginary portion of that. Now, an interesting thing is graphing these. We're going to use what's called a complex plane. Now, what a complex plane has is on the horizontal axis, same place where we've had x on a traditional plane, we're going to have the real number, the A. On the vertical axis, we're going to use the imaginary portion, which will be B, on the same position as on a traditional axis where y would be. So if I have to graph -3 minus 4i, I'm going to go 3 to the left, 1, 2, 3, and I'm going to go down 4. 1, 2, 3, 4. So that graph's right here. Now, one of the reasons why we graph it is we're trying to find the absolute value. Now, the absolute value is going to represent the distance on the complex plane, and we're going to use Pythagorean theorem. So I'm just trying to find out this distance from here to here. If I draw a triangle, I know this distance was 3, and this distance was 4. So I will just use 3 squared plus 4 squared, which is turning out to be square root of 25 or 5. So our final formula will look like such. The absolute value of the complex number will be the square root of a squared plus b squared. The negative numbers will not affect the absolute value. We will only use the positive a and the positive b to get this solution. Now, when we're adding and subtracting, what we'll do in this case, okay, I'll go ahead and add and subtract this term. What I'll do is combine the regular numbers. 4 minus 8 is -4. 2i minus 6i will be 2i minus a minus, so it's plus 6i, so it's going to be plus 8i. So when we add them, we're fine. And subtracting, same thing. Now, multiplying is a little more complicated because of the I squared involved. Okay? If I go to multiply this out, I'll use distributing. 2 times 5 gives me 10. 2 times -4i will be -8i. 3 times 5, 3i times 5, excuse me, is plus 15i. 3i times -4i is -12i squared. Now, as I do this, I'm going to take a minute and deal with this because this is most different. That becomes -1. -12 times -1 will be a positive 12. So I have 10 plus 12, or 22. -8i plus 15 will give me plus 7i. So when you multiply complex numbers, you'll receive a complex number in return. Now, I could multiply something like this. 3i times, let's say, 4i. If I just are multiplying that group, we'll have 3 times 4, or 12. I times I is I squared. I squared will give me a -1. So it's basically like saying 12 times -1. So that solution would be -12. Okay? Now, dividing is a whole other issue. So with dividing, what we have this process called the complex conjugate. Okay? Now, I want to refer back to when we first learned how to work with the difference of squares. Okay? At some point, we've learned how to multiply something like this. X plus 4 times x minus 4. When I multiply this out, I have x squared plus 4x minus 4x minus 16. The middle terms cancel out. I'm left with x squared minus 16, two terms. Okay? So complex conjugate is a similar process. The a is the same, but b is the opposite sign. So if I have 4 plus 2i, the complex conjugate is going to be 4 minus 2i. When I multiply those out, remember the 8i and the negative 8i will cancel out to 0. 4i squared, b is like saying 4 times negative 1, which gives me positive 4. So I have 16 plus 4. When I multiply those together, I get a whole number. Let's try another one. How about 5 minus 6i? Okay? First of all, the complex conjugate will be the same real part, but the opposite imaginary part. Okay? I'm going to multiply 5 times 5, and I'll get 25. Now, the middle terms cancel out, so I'm not going to bother with it. Negative 6i times positive 6i is minus 36i squared. Okay? And then I'll end up dividing, or letting that be negative 1. So it's basically 25 plus 36, or that particular answer would be 61. Okay? So the dividing part, what happens here is we're looking for a shortcut method. Okay? Now what I'll do is show you a couple quick examples. If I want to find out how to divide something like this, 3 plus 4i divided by, let's say, 5i. Now, the complex conjugate of a single imaginary part will be just the negative. So I'm going to multiply this times negative 5i over negative 5i. I can multiply by 1. Okay, now the reason I'll do this, I'm going to do the bottom part first. I'm going to have negative 25i squared. Now I squared, of course, is negative 1. So in my final answer, before I simplify, I'm going to get a denominator of 25. Then I'll deal with the numerator. I'm going to distribute negative 5 times negative 3, positive 3 will be negative 15i. Negative 5 times negative 4i will be negative 20i squared. Now I squared, as we know, becomes negative 1. So I got negative 20 times negative 1 is positive 20. So I'm going to write that first. 20 minus 15i all over 25. And that will be how we divide. We cannot have I in the denominator. Let's try another one where we're going to have two parts in there. Okay? So let's try something along the line of, I'll use the same one they used here. I'll say I've got 2 plus 3i. I want to divide that by 1 minus 4i. I find the complex conjugate of the denominator only. So I have 1 minus 4i. The complex conjugate will be 1 plus 4i. I can't just multiply by the denominator. I have to put the same thing up here. So it's like multiplying by 1. So now I'm going to go ahead and distribute here. 2 times 1 is 2. 2 times 4i is plus 8i. 3i times 4 is plus 3i. 3i times 4i is plus 12i squared. In the denominator, I have my complex conjugate, so I just have 1 times 1, or 1. Negative 4i times positive 4i. Now the middle terms will cancel out, so I have negative 16i squared. Now let's do a little more simplifying. This I squared becomes negative 1, so that's a negative 12. So I get 2 minus 12, or negative 10. I've got 8 plus 3i, so I have plus 11i. In the denominator, I have negative 16i. Negative I squared is negative 1, so it's basically 1 plus 16. So that becomes this answer. That's how I simplify that, and that's how we divide. Okay? All right, let's try a couple of these got it's for a second. I got 5 minus 2i over 3 plus 4i. I'll just do this one. Let's get the complex conjugate of the denominator first. Okay, so I have 3 plus 4i. I'll do 3 minus 4i. And then the denominator needs to be exactly the same, 3 minus 4i. Let's distribute. 5 times 3 is 15. 5 times negative 4i is minus 20i. Negative 2i times 3 will be minus 6i. Negative 2i times negative 4i is plus 8i squared. In the denominator, because they're complex conjugates, I'm going to ignore the middle term. 3 times 3 is 9. 4i times negative 4i is minus 16i squared. Now let's do our final simplification. I'll deal with the I squared here, negative 1, so that's negative 8. 15 minus 8 is 7. Negative 20i minus 6i is minus 26i. My denominator should end up being a whole number. 16i squared is negative 1. So negative 16 times negative 1 is positive 16. 9 plus 16 gives us 25. There's my solution. Now lastly, when talking about factoring, this is a little complicated in some ways, but the main thing is how to factor certain parts. If I want to get the factored form of this using complex conjugates, I first do the GCF of 2, so get x squared plus 16. And what really happened was I took 16 and I broke it down to 4i times negative 4i, because that would have given us negative 16i squared, which will give us positive 16. So to factor that so we can find our zeros, I'm going to have x plus 4i times x minus 4i. Now let's try a couple of these quick check-its. So I'm going to check this one, 5x squared plus 20. I'm first going to factor out the greatest common factor of 5, x squared plus 4. Now as long as the 4 is a perfect square, I'm going to find out the complex conjugates of that. So in a way, what we're doing is we want to break this down to the square root of 4, which is 2. So I'm going to say that's going to be 2i times negative 2i. It's just another way of square rooting. So what this is going to become is 5 times x plus 2i times x minus 2i. It's a little bit different way of doing things. Instead of, if it was x minus 4, it would have been x plus 2, x minus 2. Instead, if it's positive, it's x plus 2i times x minus 2i. Now, a little bit easier might be something like this, x squared plus 81. Now, the square root of 81 is basically 9 times 9, but I'm going to write it like this, 9i times negative 9i. So I'll write it in this style, x plus 9i times x minus 9i. So that's how we're going to factor some of these. Okay, that's all for now. Thanks, folks.